Hello geometers, this is Ms. Backfish and I am here to review some topics in coordinate geometry with you for our quiz tomorrow. And the first one is, you are given two endpoints of a segment and asked to find the midpoint of that segment. Well, here are our formulas we use for coordinate geometry. We use the slope formula, the midpoint formula, and the distance formula. And I've got a glare over there, so let me bring them over here. And of course, this is the midpoint. And of course, the point formula that we need to use. I'm not in love with the whole M, but that's okay. So midpoint formula, I always say it's really the average of the x's. You're adding them together and dividing by 2, just like you would 2 test scores if you wanted the average. So you average the x's and then you average the y's. You do the exact same thing to the y's that you would do to the x's. So I'm going to add these two numbers together and divide by 2. And then I'm going to add the two y values together and divide by 2. One reason I like to point out this is the average is because notice midpoint formula is the only one of these 3 formulas where we're not actually subtracting. Okay, on these other ones we're actually subtracting, and sometimes people get confused about that. So adding is what we would do if we were trying to find the average of a group of numbers or 2 numbers, and that's what we're doing here. We want the number in the middle between this number, and that's our new x. The number in the middle between this number and this number. So negative 3 plus 5, that's 2. 1 plus negative 5 is negative 4. And my midpoint is 1, negative 2. And that is my answer. All right, let's do another one. Let's say that the midpoint, the endpoints of segment AB are 0, 7, and 8, negative 4. Okay, you can pause the video, try that one. And then pick them back up. I'm just going to add the x's together, divide by 2. Add the y's together, divide by 2. That gives me 8 over 2 and 3 over 2. 8 divided by 2 simplifies to 4. 3 halves, I would just leave like that. There's nothing wrong with an improper fraction, quote, quote. In other words, that's what they're called usually like elementary school or middle school, but it's fine to have a fraction with the numerator higher than the denominator. Okay, now if you want to graph it, if you wanted to plot it on a grid, it might be helpful to think of it as a mixed number. In other words, this is the same as 1.5 or 1.5. And so that might help you know where to put the point. But just in terms of giving the coordinates, there's nothing wrong with giving that fraction just as it is. Okay, now the next type of problem we're going to do is when we have a midpoint and an endpoint, and we're missing the other endpoint. In other words, on this section right here, you were given an endpoint and given the other endpoint, and you were asked, where is this? Okay, in contrast, what we're going to do next is more like you're given one endpoint and you're given the midpoint. Like maybe I'm given A, I'm given M, and I'm asked, where is this other endpoint? Where is that located? Okay, so let's look at an example of that. All right, so on this one, it says find B, which we're saying B is the missing endpoint, given that A is at 5, 2, and the midpoint of segment AB is at 1, 6. All right, so we could do this with the formula, but my favorite way to do this is as I'm about to show you here. I think about the endpoints, and A is one endpoint, and B is the other endpoint. Okay, and I'm going to say blank, blank, because I don't know what B is. And then I put the midpoint right in the middle between the two. And I say, how can I make this be the middle number between this and this? Well, there's a couple of ways we could approach it. The way I usually do it is I think about it as going out from the middle. And here's what I mean by that. I'm trying to find my pen here that I want to use. And struggling to locate it. Let's use this one. Okay. In other words, if this is in the middle, from 1 to 5 is going up 4. So if I want to go from the middle to the other direction, I would go down 4. So this point is at -3, that x value of this point. If 6 is in the middle, from 6 to 2, going in one direction from the middle to the end, that takes you down 4. So going the other direction would be up 4. And it's just coincidence that I used the same numbers here. I kind of did not mean to do that. Okay, so it turns out the missing endpoint is at -310. Another way of looking at it, same way, I would set it up like this, but sometimes I've had students tell me they like to think of it, and it works the exact same way, as starting at one endpoint. Okay, like I start here and I say, okay, to go from here to here, what do I do? Well, that's down 4. So I keep going in that direction, down another 4. From here to here is adding 4. And so I keep adding 4 on the other side and I get here. So you could think of it that way too. Okay, so let's do another problem like that. Let's say find, let's go ahead with this picture. We got find B, given that A is -3, -10, and the midpoint is at, excuse me, let's go with -1, -5. Okay? So again, you would want to align them like this, where you have two ends on either side of the middle. So here's an endpoint. Here's an endpoint. I don't know what it is. And the middle is -1, -5. Incidentally, you can use this whole thought process to find the midpoint on problems like we started out with too, if you would like to. Okay? So I say from -1, I go down 2, I'm at -3. So I'm going to go the other way, I'm going to go up 2. So that's at +1. If this is in the middle, then it's going to be the same direction, same distance, either direction. From -5 to get to -10, that's subtracting 5. So I want to add 5, and that'll be at 0. So my answer is 1, 0 is the missing endpoint. Now, you could always use the midpoint formula to check yourself. Remember, the midpoint formula says add the x's together, divide by 2, and you have the new x. Add the y's together, divide by 2, and you have the new y. So we could do that with these two endpoints. -3 plus 1 divided by 2 equals, let's see, -2 over 2, which is -1, which is exactly what it's supposed to have been. The midpoint has an x value of 1. -10 plus 0 divided by 2 equals -10 divided by 2 is -5, which is exactly where the midpoint was supposed to be. So that kind of checked that we were doing the right thing. All right. Okay, so those two topics that we just did, those are things that I'm going to put a quiz for on our Google Classroom. So hopefully if you need more practice with that, you will go to the quizzes. Next, I want to look at a triangle graphed on the coordinate plane and determining whether or not it's isosceles. Okay, so let's first graph it. A is at -1, 2. B is at 4, 5. And C is at 1, 0. Okay, so here's my triangle. And graphing is always going to be your first step. And then we're being asked to show that this is isosceles. You can't just say it looks like it, of course. We have to actually show how we know this is true. Well, first thing to understand is what to be isosceles. Well, isosceles means it looks like, it has two congruent sides. All right, it looks like the two congruent sides would probably be this side and this side if they are. But honestly, I'd really like to find all three side lengths just to make sure I know what I'm looking at here. So that's what I'm going to do is I'm going to find the side lengths. Isosceles triangles have two congruent sides. Congruent means the same length. And length means, if I grab my little piece of paper, distance formula. We use the distance formula to determine length. Okay, so I'm going to use the distance formula for each pair of segments. A and B has a segment, AB, B and C, and A and C. All right, so first off, segment AB And when you write the name of a segment with nothing at the top, remember that means the length of segment AB. So AB, and distance formula says subtract my x's. So 4 minus -1. Square it. Subtract my y's. 5 minus 2. And square that. Okay, if you don't believe me, there it is. Okay, so that's what I just did. Now, how do I know which one's 0.2 and which one's 1? Which one is 0.1? You don't. Like, I could have called this 0.1. Well, I kind of did. This 0.1 and this 0.2. Or I could have called this 0.1 and this 0.2. It doesn't matter. Because if you did it in the opposite order, like here, we're going to get 5. 4 minus a -1 turns into 4 plus 1. And this is going to be a 5. If you did it the other way, you would have gotten a -5. But both of those, when you square them, you'll get 25. So it doesn't matter which order you do your subtraction in at all here. On slope formula, it matters that you start with the same point each time. Like start with the same point on the y's and the x's. But for distance formula, it really truly doesn't even matter. Okay? So we've got square root of this is 5, like we said. And this is 3. So that's square root of 25 plus 9, which is square root of 34. It doesn't matter if you simplify this or not. That really doesn't simplify, but you don't have to worry about simplifying because we're just trying to show that two of them are the same. So as long as we can get them to a point where we can see that, that's good enough. All right, BC, 4 minus 1 squared plus 5 minus 0 squared. Okay? So this is 3 squared plus 5 squared, which is kind of what we got here. Same idea, just different order. So that's 9 plus 25, and that's square root of 34. So we've already shown it's isosceles. We really don't even need to find the third side. But we could go ahead and find the third side just to prove it's not actually equilateral. So AC is our third side. Remember, this is what our graph looks like. So AC is the third side. We just showed that the two have the same length. AC has a length of 1 minus -1 for the x's, plus 0 minus 2 for the y's. 1 minus a -1, that becomes 1 plus 1, which is 2. -2 over here, 0 minus 2 is -2 squared. And this is 4 plus 4, which is square root of 8. So it's not the same. So it's not also equilateral, but it is isosceles. So if I were doing a formal proof of this, if I were doing it on a test or quiz and I wanted to make sure I got all full credit, I would say ABC is isosceles because AB is congruent to BC or something along those lines. I would make a, you kind of want to make a point of, I guess, best way to describe this, pretty much summarizing for your reader, for the person who's reading the problem, what you've done. It's like, okay, a bunch of formulas. What did you do? Oh, you showed that these are congruent. That's what you did. Okay, I get it now. I see why you showed that it was isosceles. Okay, one thing I wanted to point out here is be very careful about squaring a negative number, because if you do it in the calculator, and I thought I had one handy, if you do it in the calculator and you don't tell the calculator what to do correctly, then the calculator will do what you asked it to do. In other words, if I tried to square -2 and I typed this, the calculator will tell me it's -4 because the calculator is doing what I asked it to do. What I asked it to do was actually to square 2 and put a negative in front of my answer. Okay, so if you want to square a -2, you have to include the negative in squaring by using parentheses. It's like it was not included in the squaring. Keep in mind that if you're confused about that and you square a number, remember what squared means. You can always just do -2 times -2. Okay? All right, that was showing that a triangle is isosceles. Now let's look at showing that a quadrilateral is a parallelogram. which we've done a few times this week.